Okay, in this video I'm going to talk about the differential vector calculus. In this part I'm going to talk about the divergence. So I'm going to get your attention to the divergence, so which is really important factor in when we study the vector calculus. So this divergence is it's just like a measurement of how vector field spread out from a given point. So actually when you have a vector, so let's say you have a electric field. So this electric field actually spreads in these directions, like this way. So this is how the vector field, this is electric field, so electric field spreads out from a given point. This is how the divergence looks like in real applications. So this is just a measurement of how a vector field is spread out from a given point. So this is the given point. So this is our vector. It's the E field, electric field for this example. So likewise if you have a vector field V, so this vector field, if the vector field V spreads out from a point, so that's going to be the divergence of V. So now I'm going to find a general expression for this divergence. So I'm going to define the divergence of a vector field. So what I have here is this del operator. So I'm going to del operator, I'm going to denote the del operator as in this way. So I'm going to have a dot product with the vector V, or you can say vector E or something like that. So there is a scalar. So this is a scalar product actually. So because you know that del operator is a vector, so V is also a vector. So now when we have two vectors and we have a dot product of two vectors, it will be a scalar. So you know that I have defined del operator in the previous video. So you know that dab x or dab over dab x, x hat, dab over dab y hat, and dab over dab c hat is my del operator. So now I'm going to define this v vector as vx x hat, vy y hat, and vz c hat. So now I'm going to write vx x hat and vy y hat and plus vz c hat. So I'm going to expand this dot product. So when I'm going to expand this dot product, I will have x hat dot x hat and x hat dot y hat terms. So I only get x hat and x hat dot x hat terms and y hat dot y hat and c hat dot c hat terms, because you know that from the previous videos we have seen that x hat dot x hat is equals 1 and x hat dot y hat is equals 0. So you will have daba vx over daba x, because x hat dot x hat is equals 1. So you will have daba vy over daba y, that is the partial differentiation of y, that is the partial differentiation of y vector component with respect to y. So now we have dou v is it over dou c. So this is the divergence of v. This is measurement of how vector field is spread out from a given point. So for an example, if we have a vector field like this, that means that the divergence is equals to 0. And when it comes to the divergence, this is the general expression for the divergence, so you have to remember this term, this relationship. So this is actually the x component of the vector field, and this is the y component of the vector field, and this is the c component of the vector field. So I have written this divergence with using the by using the Cartesian coordinates. So if we have used cylindrical polar coordinates, this will be different, and if you have used spherical polar coordinates, it will be different. So I think I hope you all understand about the divergence. So in the next video, I'm going to discuss about the curl, which is also a really important feature when it comes to differential vector calculus.